Hello all, welcome to GoThub. Today let us solve the LeetCode study challenge, the Paint House 3. There is a row of M houses in a small city. Each house must be painted with one of the N colors labeled from 1 to N. Some houses that have been painted last summer should not be painted again. A neighborhood is a maximal group of continuous houses that are painted with the same color. For example, if we consider the array as 1 2 2 3 3 2 3 3 2 1 1, consider these are number of houses. There are 1 2 3 4 5 6 7 8 8 yeah, 8 houses. There are 8 houses and they are colored, each house is colored with their respective numbers, like this is 1, this is colored with 2, this is colored with 3, like so on. So we can say them as neighbors if they are continuous houses with the same paints. That is these 2 and 2 forms one neighbor. This 1 forms a separate neighbor. This 3 and 3 forms a neighbor. This 2 forms a separate neighbor, and this 1 and 1 forms a separate neighbor. So how many neighbors are there? There are 1, 2, 3, 4, 5. So there will be 5 neighbors in this given houses which after painting. So given an array of m cross n matrix cost. This is the cost array. This is the where dimensions is m cross n and an integer target where houses of I is the color of the house I. So this houses of I is the color. This represents the color of that house. Houses, this you should note so that it will be more easier to understand. Houses of I is the color of that house. So then the cost of ij is the cost of the paint the house I with the color j plus 1. So this cost, so in the consider this cost, the dimension is m cross n, that is 4 cross 3. So this is the first house. The first house can be painted with either this color, first color, this either this second color, or either this third color. Similarly, in this second house, either we can color this first color or second color or this third color. So there are multiple various possibilities of this. So we have to return the minimum cost of painting all the remaining houses in such a way that there are exactly target neighborhoods. So we have to see whether we can make a minimum cost painting all the remaining houses such that their neighborhoods are equal to the target. If it is not possible, we have to return -1. So we can consider this houses array. The houses array is 0 0 0 0 and 0, and they are also given a cost. The cost array is 1 comma 10 10 comma 1 10 comma 1 this. So in this the 0 represents that the house should be painted, and if it is not 0 then the house is already painted. So we have two cases. If not 0, the house is already painted. If houses of I is 0, then it should be painted. It should be painted. So we have to paint those houses, after which their neighbors should be equal to target. So what will be the cases? Steps is nothing but it is simple. First we have to paint all the houses. Next, after painting all the houses, we have to find the neighbors count is equal to my target count. If it is so, if these conditions satisfy, we have to minimize the cost of that painting. So this is what I expected. We can walk through other examples. We can walk through this example. Here we have 5 houses. 5 houses should be painted. For the first house, the minimum cost we can take is 1. For the second house we can paint with the second color. This second color, the cost is 1. And for the third house we can take this second color. This is nothing but second. This is 1. This is 2. The color is represented in 1 based indexing. You can note that here 1 2 n. So 2. So it is given as 2. It is painted in 2, and their cost is 1. And for the fourth house we can paint with the first color, which is the cost is 1. And for the fifth house we can paint with the first color. For that the cost is 5. So the total cost for painting in this fashion gives us 9. As you can see, the house array is 1 2 2 and 1 1. So if we separate they separate them as their neighbors, what will be the neighbor count here? The neighbor count is equal to 3, which is equal to my target. So since the neighbor count is equal to target, we can consider this as one case. Even we can say we can paint in this fashion 2 2 1 2 2. Consider we are painting in this fashion. This is also the neighbor count is 3. The neighbor count is same as 3. But let us see the cost for this. For this we have painted in 2. The cost is 10 plus. For the second house we have painted with the color 2. For the second house we have painted with the color 2, which is 1 plus. For the third house we have painted with the color 10 plus. For the fourth and fifth house we have colored with the second color 10 and 1. 10 plus 1, which implies the cost is 10 plus 10 plus 10, which is 30 32. The cost is 32 cost. But for painting in this fashion the cost is just 9. So we have to minimize the cost. So the minimum optimal cost that we can obtain for this input, for this houses and this cost, it is 9. So hope you understand the problem. So let us think. So there are multiple possible ways for each non-painted house. For each non-painted house we can take this and paste here. For each not painted house we can either take n colors. If this is one not painted house, then the cost in the cost array, in that particular index, we can either take this color or this color or this color, such that their neighbors are also equal to their target. Neighbor count is also equal to target. So there are multiple possible ways, right? So if there are multiple possible ways, then we have to go for a recursive solution, so that we can take all the possible ways and we can return the minimum cost in that. So I will write a recursive function, namely I will name it as solve. I will pass the parameters as houses. First I will be needing the houses array, then the cost array, then I will pass the target array also, then I will pass the dimensions m and n. Okay, I have the m and n. Then I will pass what all I need. I am writing as a recursive function, so I will represent this houses array in indexes. So I will pass the I. I will pass the I. I starts from 0. Then I will pass the neighbor count which starts from 0. Then I will on the go I will calculate the neighbors. How we can calculate the neighbors? If the array is 1 2 2 1 1, how can we calculate the neighbors? If the if I am at this particular index, if it is different from this previous index, then I can increment my neighbor count. If I am this particular index and if my current index is equal to my previous index, then the neighbor count is same. Then again if my previous if I am at this particular index, then my if my particular index, then the current index is current index color is not equal to the previous index color, then I have to increment the neighbor count. So on the go, while the recursion takes place, I will keep track of this neighbor count. And I also need a previous index. To store the previous index, I will start from previous, I will name it as previous neighbor count which starts from 0. So this will be my recursive function. This is going to return me the minimum cost. So I will say as int answer. This is going to return me the answer. If it is not possible, I should return -1. So whenever I couldn't get any possible answer, I am going to return a maximum value. Since the problem state is minimum cost, whenever I return a maximum value, whenever I get a max cost, so I will just return if my answer equal to my max cost. I will declare a max cost constant. I will declare a const max cost which is somewhat higher value. I will say it, namely 1e8. If answer is equal to my max cost, I didn't get any minimum cost, then I will return -1, else I will return answer itself. So this is going to be in my main function. So let us copy this and code this. I will let us copy and code here. So we have returned a recursive function. We will define the recursive function as well. Before that, I will have the const value here. So this is my const value. Okay, fine. Now I am going to define the recursive function. I will have passed the vector in houses, then vector int present cost, then int target, int n, then int index, then int neighbor count. I will copy this and I will comment, since we don't want to give this neighbor count equal to 0, this previous count equal to 0, and similarly the I is equal to 0. To give an understanding, I have written this. So int I, then int neighbor count, int target, then m, then n, then I, after which I am giving the neighbor count, and then the previous neighbor count, previous neighbor. It is not neighbor count, I will say it as previous neighbor. So this will be my function. Okay, this is going to be my function. Just we will have two cases. Either the house is already painted, or my house is yet to be painted. So these are the cases. What it signifies: houses is already painted, then it is houses of I. If it is already present, then what I can say is I will have a minimum cost variable, min cost, namely, which is min cost, which is I will have a maximum value initially. I'm going to return final. I'm going to return this minimum cost value. If my houses of I is already painted, then I should calculate the neighbor count. How can I calculate this neighbor count? If my neighbor, I will say it as a new neighbor count is nothing but if my current houses of I, the color of houses of I is equal to my previous neighbor. If my houses of I, current houses of I, if my current color is equal to my previous neighbor, then my neighbor count is not going to increase, or else my neighbor count increases, neighbor count plus 1. We have calculated the new neighbor count. Then we can just call the we can just calculate the min cost by changing our index. Houses, then the cost, then target, m, n, then I plus 1. I'm going to the next index and doing the recursive call. Then it does new neighbor count. Then now my current neighbor becomes my previous neighbor for the next iteration. So I will send the current neighbor as current color becomes my previous neighbor, houses of I. So this will be my if house is already painted condition. Else, if my house is not yet to be painted, that is houses of I is 0. If my houses of I is 0, what it signifies is I have n colors. I have to paint all the colors. So I am going to try out all the possible colors. In color is equal to 0. It starts from 0 till color less than n, color plus plus. Again I have to calculate this new neighbor count. Now my houses of I is not my neighbor. Now I have to paint. So if I want to paint the color, paint the house, now I have to paint the house. Then the color is nothing but the houses of I. So color plus 1. It is 1 based indexing, 1 to n. So color plus 1. If my color plus 1 is equal to my previous neighbor, then my neighbor count is stays the same. Else I have to increment my neighbor count. So I have calculated the new neighbor. Then I will have a current cost value. Then the current cost value is nothing but I have to go for the next recursive call. Before going to my next recursive call, I will add my cost. How can I add my cost? I have the cost array. The cost of I of color. Cost of I of color gives me the cost of that particular index to paint the house, plus I'm going to my next recursive call. Just solve houses, then cost, then target, m, n. I'm going to my next index I plus 1. Now my new neighbor count. Now my previous neighbor, what is my previous neighbor? Now for next iteration, next recursive call, the previous neighbor is nothing but the current painted color. Current painted color is nothing but the color plus 1. So color plus 1 is the previous neighbor for the next iteration. So I have calculated the current cost. After calculating the current cost, I have to update my min cost value. Min cost is nothing but the minimum of my min cost or my current cost. And finally I am returning the min cost value. Now we have coded all the conditions, but what will be my base cases? We have to write a base case for any recursive problems. So what will be my base case? Only whenever my neighbor count, only whenever my neighbor count is equal to my target. Sorry, before seeing this condition, if my I have reached my end of the array, size of the array, that is m. If my I has reached the size of the array, then if my size has reached the array, I have to check whether my neighbor count, neighbor count is equal to my target count, target neighbor. If it is equal only, then I can say, if my neighbor count is equal to my target only, then I can say I have calculated some cost. Then I have to say return 0. Correct. Return 0. Else I can return max cost. Correct. If my neighbor count is equal to target, then I will return 0. Else I will return max cost. So this will be my base case. If somewhere I got my neighbor count to be greater than my target, then I can directly return max cost, so that I will not be including that path in my answer. I will break that path instead of going for next recursive calls. So these are all my base cases, and we have written the recursive code. We can just run the code and see, but here the time complexity will go exponentially, since we are trying all possible ways. We'll just run the code and see. Hope you got some understanding how it is implemented. Okay, const init. It got accepted. We will use the example test cases as well. It got accepted. Before submitting, we know that it is going to give time limit exceeded. Since it is a recursive solution, it is going to give obviously the time limit exceeded. So let us try to convert this into a DP problem. To convert into a DP problem, memoization technique is used for recursive approach. So to convert it to a memoization, what we have to do is, we have to see what are all the changing parameters in the recursive function. The changing parameter is I, then neighbor count, then my previous neighbor. What is the range of I? We can see the constraints. The range of I is nothing but m. M is nothing but 100. Only it goes till 100. So we need a dimension, one dimension, which is of 100. We will say 101. Right? Okay, 101. Then we need this neighbor count. Neighbor count is nothing but the houses of value. Houses of I value is nothing but n. N goes till 20. This neighbor, sorry, the previous neighbor only, the houses of I. The houses of I value is nothing but the previous neighbor. The previous neighbor dimension will be 20, which is 21. We will define that 21 before that neighbor count. We will see neighbor count. If my houses of I is 1, 2, 3, 4, 5, 6, 7, 8, it goes on till this. So my neighbor count is what? Neighbor count is nothing but for each value, each house I'm giving a separate color. For each house, if I'm giving a separate color, then the neighbor count grows till m. So I will give the neighbor count dimension as 101. It goes maximum of 100. And the previous neighbor is nothing but 21. Since the houses of I values just n is nothing but the 20, so 21. So this will be my DP, three-dimensional DP. Before that, we will initialize memset dp of -1 is initialize size of dp, after which after the base cases we have to check if if the answer is already computed, return the value. This is what we are doing here. dp of I of neighbor count previous neighbor. If it is not equal to -1, then we will just return this value dp of I neighbor count previous neighbor value, and we have to cache this where we are going to cache here previous dp of I neighbor count previous neighbor is equal to min cost. So we have cached and we have converted into a dp solution. So what will be the time complexity here? We will calculate the time complexity also. The time complexity is nothing but we have used a 3-dimension. So 3-dimension is nothing but m into n. So this will be my time complexity. And what is my space complexity here? Space complexity is nothing but m into n. So this will be my time complexity and space complexity. This is a 3D DP approach. I have walked you through the recursive solution. Then I have given the memorization solution. We will try to run the code. Now we will try to submit the code. Superb, it got accepted. Hope you liked this video, and let us see in tomorrow's LeetCode challenge. Until then, bye.